Hello, students. I just planned to do a video on the homework for week 8 because you have to turn in a final term paper, and I thought a little bit of help here, support here would speed up matters. So let's get into a few questions that I'm going to show you how to work out. Here is number 1. 2 raised to x is equal to 16. Or 2 to the power x is equal to 16. So what we are trying to do is, we are trying to write 16 with base 2. And you know, 16 can be written as 2 raised to 4. Because 2 times 2 times 2 times 2, that's 4 times, would be 16. And remember that when the bases are equal, like 2 here and 2 here, the powers can be set equal to each other. Again, if the bases are equal, then the powers must be equal, which means x is equal to 4. So here I'm just showing that 2 raised to 4 is 16. Okay, so that's how you do number 1. Here's number 2. 8 to the power x is equal to 16. Now what we do is the same idea. We can write 8 as 2 raised to 3. Because 2 times 2 times 2 is 8. So now you have to write 2 raised to 3 raised to x is equal to 16. And on the side, again, 16 is 2 raised to 4. Now what we do is, remember that a raised to b raised to c is actually a raised to b times c. Or in other words, 2 raised to 3 raised to x is the same as 2 raised to 3x. Okay, so 2 raised to 3x is 2 raised to 4. And now, when the bases are equal, the powers need to be equal to each other. So 3x is 4. All right. 3x is 4 and x is 4 by 3. That's all. So here I was trying to explain what I did. A raised to b whole raised to c is nothing but a raised to b times c, which is what I've used here. Hope that makes sense. Here's number 3. 2 raised to x is equal to 1 by 16. 2 raised to x is equal to 1 by 16. So we're again trying to write 1 by 16 with a base 2. So it should be 2 raised to something, okay? So here's the deal. 2 raised to x is equal to 1 by 2 raised to 4. And then 1 by 2 raised to 4 is 2 raised to negative 4. That means 1 by a raised to b is nothing but a raised to minus b. So when you take this to the numerator, you just change the sign. All right, now the powers can be put equal to each other because the bases are the same. So x is negative 4. So this is what we used here. 1 by a raised to b is a raised to minus b. All right, let's go to the next. So here we have 20 raised to x is 0.05. At the outset, this looks a little tough, but not really. 20 raised to x is 0.05. Remember, our idea is to have the same base so that we can set the powers equal to each other. So 20 raised to x is 5 by 100. So 0.05 is 5 by 100, right? Yes, it is. And then 5 by 100 is 1 by 20, because you can divide the numerator and the denominator by 5. And so you get 1 by 20. And remember that, okay, so that's how I got 1 by 20. And once you have 1 by 20, like we did in the last one, it's nothing but 20 raised to minus 1. 1 by 20 is 20 raised to minus 1. Once again, we got the bases to be equal, so we can put the powers equal to each other. So x is equal to minus 1. Here we go to the next. 5 by 4 raised to x is equal to 64 by 125. Okay, that's given. You have to find x. 5 by 4 raised to x. So 5 by 4 raised to x. I don't do anything there. On the right side, 64 is 4 raised to 3 and 125 is 5 raised to 3. Isn't it? Because 4 times 4 times 4 is 64 and 5 times 5 times 5 is 125. So we got that, and then we can write 4 by 5 whole raised to 3. Oh, that's another rule. So if you have 4 cubed by 5 cubed, that can be written as 4 by 5 whole raised to cube or whole raised to 3. So now what do we have? We have 5 by 4 raised to x is equal to, oh, I switched the side. You see what I did? Instead of writing 4 by 5, I put it as 5 by 4. That means I have to change the sign. So now instead of 3, I have negative 3. So 4 by 5 became 5 by 4, and then the power 3 became negative 3. We got the base to be the same again, so x is equal to minus 3. I hope all this is making sense. We have a couple more to go, at least. So this is of a different type. Here's a function a as a function of t, where t is time, is given by this equation. 650 times 3.8 raised to negative 0.5t. And then what is the value of a t for the initial measurement? So for the initial measurement means t is equal to 0, isn't it? So what is the value of at? Whenever you see the initial measurement, that means at time t is equal to 0. So all we got to do is substitute the value of t here as 0. And when we do that, we will get the value of the function. So that's 650 raised to 3.8 raised to 0, because when you multiply anything with 0, it becomes 0, right? So 0.5 times 0 is 0. And anything raised to 0 is 1. That's another important rule. Anything raised to 0 is 1. So now we have 650 times 1, which is 650. That's the answer. Okay, here's the next. Wow, that's a big question. Let's read it. A major scientific periodical published an article in 1990 dealing with the problem of global warming. The article was accompanied by a graph that illustrated two possible scenarios. A, the data might be modeled by an exponential function, and the function is given. I'm not reading that. And in B, the warming may be modeled by a linear function, which is again given. So you have A as an exponential function, and B you have as a linear function. And then the question is, in both cases, x represents the year, and the function value represents the increase in degrees Celsius due to the warming. It shows how much the temperature increases. Use these functions to approximate the increase in temperature in 1999. All right, if you look at here, you know that this article was published in 1990, and we have to forecast how much the temperature will increase by the time it's 1999. Okay, so let's do that. In order to do that, let me write the function. This is the function that was given. Now, in place of t, I'm substituting 1999. So, okay, 1.044 raised to 1999. So in the function, it was function t is equal to this big number 1.044 raised to t. So wherever I have t, we have substituted 1999 and then do the calculation. This one I'm just writing as it is. So you actually get 2.1. All right, so this is what you do. You find 1.0444 raised to 1999 is actually 5.186 times 10 to the 37. Then you multiply these two numbers, and then remember that this is 10 to the negative 1. So that's going to give 2.097 to the 10th place is 2.1. Hopefully that made sense. Here's the next. Okay, then it's asking you to find the other function. Do the same for the other function. Just again, where you have t, put 1999. It's a linear function, and calculate it. You get 17.991 minus 17.65, which gives 0.3. That's how we do that. All right, so the last question here, I'm just doing one part of that. It says a small business estimates that the value of a copy machine is decreasing according to the given function. You know, as years pass, the value of anything decreases. And so here t is the number of years that have elapsed since the machine was purchased. So remember here t is not the year, it's how many years have passed. And v as a function of t is in dollars. Okay, so there are parts A to D. I think I'm just doing one part. What was the original value of the machine? Now, to find the original value of the machine, you got to put t is equal to how much? T is equal to 0. Because 0 time has passed. When you just buy it, you just bought it. So put t is equal to 0, and that will give us the answer. So here's the function. And then you have 6,000 times 2 raised to negative 0.13t. That's a given function. And then we're going to put t is equal to 0. Remember that anything raised to 0 is 1. So you're going to get 600 times 2 raised to 0. And 2 raised to 0 is 1. So 6,000 times 1 is 6,000. So that is how much it was worth. There is a B part, which I've also done. You have to find the value after... It says 5 years, so just put t as 5 now and do the same. So 6,000, 2 raised to negative 0.13 times 5. You see where t is? I've just substituted the value as 5 because 5 years have passed. And then in the calculator, find the numbers. So this is going to be, you know, when you multiply, you get negative 0.65. And then you have to find 2 to the power negative 0.65, multiply that with 6,000, and you get 3,824. Wow, it lost a lot of value. Remember, it began at 6,000, and after 5 years, it's only worth $3,824. So that's how we do these problems. I think I have one more. Okay, so here is a function. Right. And that's the function. And here the question is a little different. It says, when will the value of this function become something? So when will the value of the machine become these many dollars, $1,600? So here you see the difference is, now you're given the value. And you have to find after how many years. It drops to 1,600. So where you have the value, you put 1,600 and then work or solve that equation. Okay, so we have that. We cannot do anything with t because we do not know anything about t. We're trying to find that. And then first, divide both sides by 4,800. Okay, so the 4,800 will cancel out on the right side. On the left side, it becomes 1 by 3. And then you have 3 raised to that. I hope you already saw that. You know, 3 raised to negative something can be written as 1 by 3 raised to positive. So that's the trick. 1 by 3 raised to, you see the negative sign is gone there. It's only positive now. And that means you can take the reciprocal of both. So you can reverse or invert both, which makes it 3 is 3 raised to 0.17t. Remember, 3 means 3 raised to 1, right? Because any number raised to 1 is the number itself. Now, why did I write it that way? To show that the bases are the same, so the powers can be set equal to each other. I don't know how many times I would have said that. And then you do that, divide both sides by 0.17, and you do the math, you get t as 5.88 years. So that's how you work out these problems. I know I try to go a little bit fast, but you can pause and listen to it again, try to understand. Hopefully this has made it a little bit easier for you. Now I've done this also because I want you to do the end of term assignment paper, which actually carries 150 points. So please start working on that and let me know if this is useful. Put your comments under the YouTube video. Thank you so much. See you on the next one.